In the last video, I was a little formal in defining what Rn is and what a vector is and what vector addition or scalar multiplication is. In this video, I want to kind of go back to basics and just give you a lot of examples and give you a more tangible sense for what vectors are and how we operate with them. So let me define a couple of vectors here. So and I'm going to do, most of my vectors I'm going to do in this video are going to be in R2. And that's because they're easy to draw. R2, remember, R2 was a set of all two tuples, ordered two tuples, where each of the numbers, so you could have x1, and let me see, my 1 looks like a comma, x1 and x2, where each of these are real numbers. So each of them, x1 is a member of the reals, x1, and x2 is a member of the reals. And just to give you a sense of what that means, if this is right here is my coordinate axes, and I wanted to plot all my x1s, x2s, right? This could be, you could view this as the first coordinate. We always imagine that as our x-axis. And then our second coordinate, we plotted on the vertical axis that traditionally is our y-axis, but we'll just call that the second number axis, whatever. You could visually represent all of R2 by literally every single point on this plane if we were to continue off in infinity in every direction. That's what R2 is. R1 would just be points just along one of these number lines. That would be R1. So you could immediately see that R2 is kind of a bigger space. But anyway, I said that I wouldn't be too abstract. I would show you examples. So let's get some vectors going in R2. So let me define my vector A. I'll make it nice and bold. My vector A is equal to, make some numbers up, -1, 2. And my vector B, make it nice and bold. Let me make that is, I don't know, 3, 3, 1. Those are my two vectors. Now let's just add them up and see what we get, just based on my definition of vector addition. And I'll just stay in one color for now, just so I don't have to keep switching back and forth. So A, nice deep A, plus bolded B is equal to, I just add up each of those terms, -1 plus 3, and then 2 plus 1. That was my definition of vector addition. So that is going to be equal to 2, 2, and 3. Fair enough. This just came out of my definition of vector addition. But how can we represent this vector? So we already know that if we have coordinates, if I have the coordinate, and this is just a convention, it's just the way that we do it, the way we visualize things. If I wanted to plot the point 1, 1, I go to my coordinate axes. The first point, I go along the horizontal, what we traditionally call our x-axis. And I go 1 in that direction. And then the convention is the second point, I go 1 in the vertical direction. So the point 1, 1, I would, oh, sorry, let me be very clear. This is 2 and 2. So 1 is right here, and 1 is right there. So the point 1, 1 would be right there. That's just the standard convention. Now, our convention for representing vectors are, you might be tempted to say, oh, maybe I just represent this vector at the point -1, 2. And on some level, you can do that, and I'll show you in a second. But the convention for vectors is that you can start at any point. Any point, let's say we're dealing with two-dimensional vectors. So you can start at any point in R2. So let's say that you're starting at the point, x1 and x2. This could be any point. Any point in R2. To represent this vector, what we do is we draw a line from that point to the point x1. And let me call this, let's say that we wanted to draw A. So x1 minus 1. So this is, I'm representing A. So this is, I want to represent the vector A. x1 minus 1, and then x1 plus 2. Now, if that seems confusing to you, when I draw, it'll be very obvious. So let's say I just want to start at the point, let's just say for quirky reasons, I just pick a random point here. I just pick a point, that one right there. That's my starting point. So -4, 4. That's -4, 4. Now, if I want to represent my vector A, what I just said is that I add the first term in vector A to my first coordinate, so x1 plus minus 1, or x1 minus 1. So my new one is going to be, so this is my x1 minus 4. So now it's going to be, so let's see, I'm starting at the point minus 4, comma 4. If I want to represent A, what I do is I draw an arrow to minus 4 plus this first term, minus 1, and then 4 plus the second term, 4 plus 2. And so this is what? This is minus 5, comma 6. So I go to minus 5, comma 6. So I go to that point right there, and I just draw a line. So my vector will look like this. I draw a line from there to there, and I draw an arrow at the end point. So that's one representation of the vector minus 1, 2. Actually, let me do it a little bit better, because minus 5 is actually it's a little closer to right here. Minus 5, comma 6 is right there. So I draw my vector like that. Like that. But remember, this point minus 4, comma 4 was an arbitrary place to draw my vector. I could have started at this point here. I could have started at the point 4, comma 6 and done the same thing. I could have gone minus 1 in the horizontal direction. That's my movement in the horizontal direction. And then plus 2 in the vertical direction. So I could have drawn, so minus 1 in the horizontal and then plus 2 in the vertical gets me right there. So I could have just as easily drawn my vector like that. These are both interpretations of the same vector A. And I should draw them in the color of vector A. So vector A was this light blue color right there. So this is vector A. This is vector A. Sometimes there'll be a little arrow notation over the vector. But either of those vectors, I could draw an infinite number of vector A's. I could draw vector A here. I could draw it like that. And vector A, it goes back 1, and up 2. So vector A could be right there. Vector A. Similarly, vector B. What does vector B do? I could pick some arbitrary point for vector B. Some arbitrary point. It goes to the right 3. So it goes to the right 1, 2, 3. And then it goes up 1. So vector B, one representation of vector B looks like this. Another representation, I could do it right here. I could start it right here. I could go to the right 3, 1, 2, 3, and then up 1. This would be another representation of my vector B. There's an infinite number of representations of them, but the convention is to often put them in what's called the standard position, and that's to start them off at 0, 0. So your initial point, so let me write this down. Standard position. Standard position is just to start the vectors at 0, 0, and then draw them. So vector A in standard position, I would start at 0, 0 like that. And I would go back 1 and then up 2. So this is vector A in standard position right there. And then vector B in let me write that. That's A. And then vector B in standard position is 3, go to 3 right, and then up 1. But these are the vectors in standard position, but any of these other things we drew are just as valid. Just as valid. Now let's see if we can get an interpretation of what happened when we added A plus B. A plus B, well, if I draw that vector in standard position, I just calculate it, and it goes 2, 3. So I go to the right 2, and I go up 3. So if I just draw it in standard position, it looks like this. It looks like this. This vector right there. That vector right there. And at first, when you look at it, so this vector right here is the vector A plus B in standard position. When you draw it like